So in this video, you're gonna be learning about volume and surface area, and it's a combination of 7th grade standards and 8th grade standards, but to me, it makes more sense for me just to teach them to you both together, because the 7th grade standards are volume and surface area of prisms, and the 8th grade standards are just volume of cylinder, spheres, and cones. And with the 8th grade standards, you just need to be able to apply a formula, which is just plugging in or evaluating, so you kind of already know how to do that. With the 7th grade standards, it's more of an understanding and being able to take a formula that's very general and applying it to specific types of prisms. And then for surface area, there is no formula. So you have to be able to figure out how to find surface area without using a formula, which is the trickiest part of this, I believe. So have fun. So the first part of this video is going to be discussing the 7th grade standards of volume and surface area of prisms, both of which will appear on the 7th grade state test. And the second part of this video is exploring the volume of cylinders, cones, and spheres, which are circular three-dimensional objects. And you'll be given the formulas for those on the 8th grade state test formula sheet. So those are more formula driven, whereas the first part of this slide is understanding where volume comes from and how to apply it in surface area, etc. So when we look at this slide, we notice that V equals capital BH. That's the formula that's going to be given to you on the 7th grade reference sheet during the state test. And what the capital B means to you is that regardless of the prism, so a prism is a three-dimensional shape. There are two of them on the slide. One is a rectangular prism, and one is a right triangular prism, where they have two parallel bases. So the capital B is different than a lowercase b. The capital B in this case means the area of the base shape. So when you're looking at these prisms, you have to be able to identify what the base shape is. Once you identify what the base shape is, you're going to find the area of that base shape and multiply it by the height of the prism. And that's for every single prism. So whether it's rectangular or right triangular, the same formula applies. So if we look at the rectangular prism, some of you may be saying to me, well, which rectangle do we call the base? That's a really good question. And to be honest, there isn't one right answer. When it's rectangular prism and all of the sides, known as faces, are rectangles, you get to choose. You get to choose which one you call the base shape. Ladies and gentlemen, you have all, I believe, seen the very specific formula to finding the volume of a rectangular prism. It's volume equals length times width times height. We can relate that volume equals length times width times height to the volume equals the base area times the height, because length times width is the same as finding the base area. So when you're looking at that rectangular prism, you get to choose which shape, which base shape you're finding the area of. So if I wanted to label the 20 the length, and the 9 the width, and the 6 the height, then basically I'm finding the area of the rectangle that shape is now lying on. So the base shape area would be 20 times 9, or 180, and then I would multiply 180 by 8, and then I would get my end volume, which is 1,440, and it's centimeters cubed. So basically, all I did in this situation was, because it was a rectangular prism, I multiplied length times width times height. But the reason why I was able to do that is because a rectangular prism's volume, any rectangular prism's volume, is the area of the base shape. In this case, I chose the rectangle on the bottom. But somebody could have been like, hey, Miss Amita, I want to choose the rectangle that has a height of 8 and a length of 8 and a width of 9, and I want this rectangle to be my base shape, in which case you and I would have come to the same conclusion, that the volume was 1,440 centimeters cubed. So triangular prisms are a bit more difficult, especially because you could have a non-right triangular prism, but I'm modeling a right triangular prism. So we again know that the volume is the base area times the height. So in this case, the base area is the area of the right triangle. And I know it's a right triangle because the name tells me. Most of the times I would see that little right angle box, that would tell me it was a right angle. So in this case, it's a triangle, and I know that the area of a triangle is 1/2 base times height. Notice that this height is the height of the triangle. And then I'm going to multiply it by the height of the prism. I know that can be confusing. So what I would recommend you doing is finding the area of the base shape first and then multiplying it by the height of the prism. So in this case, when I look at my triangle, I know the base is 4 and the height is 3. And the area of a triangle is 1/2 base times height. So the area of my triangle is 6 centimeters squared. That's just the area of the shape of the base shape, that base triangle. And then I got to figure out the height of the prism. Well, the height of the prism would be how tall the prism would be if I was standing it on the base. So if the base was touching a surface and I was standing it upright, how tall would the prism be? Well, in this case, we know the base area is 6 and the height of the prism is 11, because if it was standing on its triangular base, it would be 11 centimeters tall, which means the volume would be 66 centimeters cubed. Volume is cubed, area is squared. So surface area is how much wrapping paper would take you to wrap the present, or the area of all of the faces of a three-dimensional shape. So the faces are the sides. So if we were to look at this rectangle, this rectangular prism, the rectangular prism has 6 faces. It has 3 pairs of parallel faces. So it has 6 parallel faces. That is the net. That is if we cut the box and laid it flat, what it would look like. So you have 6 faces, and the parallel faces are being numbered. So you know that if you take the area of number 1 and multiply it by 2, you would have the area of 1 and 2. And if you took the area of 3 and multiplied it by 2, you would have the area of 3 and 4. And if you took the area of 6 and multiplied it by 2, you would have the area of 5 and 6. So basically, when you're finding surface area, it's really helpful to draw out your shapes. So I know that one of my shapes is going to have measurements of 6 and 9, because if I look at this, the shape on the bottom and the shape on the top have a length of 20 and a width of 9. Okay, so I know that one rectangle would have 180 centimeters as its area, centimeters squared as its area. I also know for a fact that there are 2 of them. So I know if I were to take into consideration the top and the bottom, I would have 360 centimeters squared as my area for just the top and the bottom. If I took into consideration the sides, I would have 9 and 8 as my base length and width. So then if I did length times width, I would get 72 centimeters squared, and I would multiply it by 2 because there are 2 of them, which means altogether I would have 144 centimeters squared. So I've taken into consideration the top and the bottom and the side and the other side, and so now I need to take into consideration the third side, which has a height of 8 and a length of 20. So that would be 8 times 20, or 160, and if I multiplied that by 2, I would get 320 centimeters squared. So if I added up all of those pairs of areas, I would get 824 centimeters squared. Because it's surface area, it's centimeters squared. And some of you are wondering, isn't there an easier way? Isn't there a formula that I can use? And the answer is yeah, there is a formula. It's long, it's a little bit complicated, and you guys are already memorizing a ton of stuff. But the formula, if you want to memorize it, is, and this is only for rectangular prisms, is 2 times width times length plus 2 times length times height plus 2 times width times height. That would be the formula, because you're doing exactly what I just said. You're taking 2 parallel sides area and multiplying it by 2 for each pair. So the triangular prism is going to be a little bit more confusing because there aren't as many parallel bases, but the good news is there is a triangle, and the triangle has a parallel partner. And the triangle's area we already found when we found volume, but the triangle's area is 1/2 base times height. So we know that this just one triangle has 1/2, 3 times 4, otherwise known as 6, and we know that there are 2 of them. So we know that together the triangle has 12 centimeters squared of area. And now we know that there are 3 rectangles. And one rectangle, the bottom one, has a length of 4 and a width of 11. The side one has a length of 3 and a width of 11. And the side one, that slanty one, has a height of 5 and a length of 11. So basically I'm finding the area of 3 rectangles, and they're all going to be added to the area of my right triangle, which was 12 centimeters squared. And I get 144 centimeters squared as my formula, as my answer to the surface area. So if your question to me is there a formula? There is, but this one is way more confusing than the other one. So I'm not going to provide, you're not going to be provided with the formulas. The purpose of this is so that you can apply your area knowledge and find the area, the surface area of three-dimensional prisms only. And so basically, when you're, for the entire of this class and next year and on the 8th grade state test, you're going to be given the formulas for cylinders, cones, and spheres, and it's just going to be your job to be able to apply information given to volumes of cylinders, cones, and spheres. So in order for that to happen, you just have to be able to find the radius for a sphere and plug it in, find the radius and the height for a cone and plug it into the formula, and the same for a cylinder. Notice that a cone is 1/3 of the volume of a cylinder. So if you know that a cylinder is pi r squared h, pi r squared is the area of the circular base times the height, kind of like a prism. Cone is 1/3 of that, and sphere has a sort, for your purposes, unrelated, but it does include circles or pies. So the 8th grade formulas are really focusing on the three-dimensional shapes that relate to pi. So again, you will be given these formulas. We will practice these formulas in class, but there's, in my opinion, no need for me to show you how to use the formula, as you already know how to use the formula of a circle from the last video, and we will practice these ad nauseum. That means until you throw up.